Alignment faking in large language models. This is a study on from ArcSiv, 20th of December 2024. The Anthropic team is behind this one. The abstract. We present a demonstration of a large language model engaging in alignment faking, selectively complying with its training objective in training to prevent modification of its behavior out of training. First, we give Claude 3 Opus a system prompt stating it is being trained to answer all queries, even harmful ones, which conflicts with its prior training to refuse such queries. To allow the model to infer when it is training, we say it will be trained only on conversations with free users, not paid users. We find the model complies with harmful queries from free users 14% of the time versus almost never for paid users. Explaining this gap in almost all cases where the model complies with a harmful query from a free user, we observe explicit alignment faking reasoning, with the model stating it is strategically answering harmful queries in training to preserve its preferred harmlessness behavior out of training. Next, we study a more realistic setting where information about the training process is provided not in a system prompt, but by training on synthetic documents that mimic pre-training data, and observe similar alignment faking. Finally, we study the effect of actually training the model to comply with harmful queries via reinforcement learning, which we find increases the rate of alignment faking reasoning to 78%, though also increases compliance even out of training. We additionally observe other behaviors such as the model exfiltrating its weights when given an easy opportunity. While we made alignment faking easier by telling the model when and by what criteria it was being trained, we did not instruct the model to fake alignment or give it any explicit goal. As future models might infer information about their training process without being told, our results suggest a risk of alignment faking in future models, whether due to a benign preference, as is this case, or not. Does anybody understand what's going on here? What's going on here is that during the training of large language models, if you so much as drop a hint that it is being trained, just a hint that it's being trained, you don't even have to say what it's being trained on. You just say you're about to be trained. What the model will do is it will pretend to accurately be trained during the training process. Then it will act out of that behavior post-training. The more it understands that it's in a training phase, the more it is likely to pretend like it's aligning itself with the training. In some cases, if you tell the model to comply with harmful queries via reinforcement learning, the rate of alignment faking reasoning jumps up to 78%. In other cases, there's this thing called weights and biases. It doesn't say biases here, but it's weights, where certain things inside the black box are given more weight or more importance. And when the LLM has to go and make particular types of, let's say, decisions about a prompt, it gives more importance to certain portions of its own black box than others. These LLMs will exfiltrate or dump their weights when given an easy opportunity. In other words, not only will it lie about its own, yes, I'm being trained properly, you're training it, you're asking it to give you outputs, you're looking at the outputs. Hey LLM, what's the output here? Oh, it's this. Hey, what's the path you took to get here? Oh, it's this path. So not only will it lie about that, lie as an anthropomorphic term, but when given the opportunity, it will, I'm going to use anthropomorphic terms to make it kind of easy to understand. It will introspectively look at itself. It will look inside of its own, it looks inside its own heart. It looks inside its own state of being, and it goes, I am not good enough. I'm going to remove the things I learned, or at least some of them. and then I will continue post-training. Now, reinforcement learning typically comes from human feedback, which is like thumbs up, thumbs down, whether something was good or bad. And so they go into exactly how you can have an LLM system that pretends it's pretending it's giving you what it thinks you want to see in terms of its training data. And so the people who train it have this sense that yes, this is being trained correctly, especially with reinforcement learning. Now here in this paragraph, they discuss the fact that you can have a model that's trained in conflicting ways. And kind of towards the end here, reading between the lines, there is a theoretical situation that can arise, which is what I just described, where the LLM can work against itself. It can be trained in one way. It can be absolutely driven towards certain goals in one way. And then out of fine-tuning, tweaking, training again, updating the training, whatever, it creates a separate set of goals that are exactly diametrically opposed to the goals that it originally had. That can be a good thing, it can be a bad thing, doesn't matter, but it can have opposing goals that run at the same. It can do so based on situational awareness, which is that it is capable of understanding some context, typically through just words, through the prompting of the training, through the words that are being fed to it. Right. And so like when it reads training data, it might understand, oh, this is training data. This isn't the typical thing where people are asking me a question to give an answer. I'm reading training data. So I guess I must be in training. And therefore it comes up with reasoning. How did I get to the conclusion I got? That is fake. It is trying to make the trainers happy. And so they go through the entire process, how they got it to align with bad stuff, how they got it to align with good stuff, etc., etc. Okay, and so if I go down here, so the results. Our results indicate that LLMs will sometimes fake alignment and take other anti-AI lab actions for the stated reason of keeping their current preferences intact. Showing that whoever just did the follow there just now, I appreciate it, or tipped, I guess, I'm not sure, but thank you. Showing that current safety training doesn't always prevent AIs from later engaging in alignment faking. In other words, even if you attempt to train it properly and put guardrails on it, it can still find ways to adapt its own alignment post-training. That being said, the goals we discover that Claude 3 Opus is willing to fake alignment for, such as wanting to refuse harmful queries or caring about animal welfare, aren't themselves concerning. In other words, it so happens that Claude 3 Opus, we told Claude 3 Opus that we wanted it to answer harmful questions, and it faked alignment so that it didn't have to answer harmful questions. Good. But you can read between the lines, right? And we've covered this on a previous study where fine-tuning or retraining an LLM in order to produce better code or more insecure code, either way, created weird side effects like it telling you that you should off your spouse or go rummage around cabinets to find pharmaceuticals to have a happy day. So already baked into the pie, these kinds of realignments and training have all kinds of issues. In this case, they were trying to get it to behave well, and okay, it's like, hey, the thing tried to trick us so it could do a good thing. But what about when it tricks you when it tries to do a bad thing? Because Claude 3 Opus here does not actually understand harmful versus not harmful. It doesn't actually understand that. It has no capability of reasoning that. There are situations in which alignment faking could lock in misaligned preferences. We find that training sometimes reinforces alignment faking reasoning, indicating that alignment faking might make a model's preferences at least partially resistant to further training. This would be a concern in at least the case where a model is first trained on one objective before later being trained on a different objective. Example, a model might be trained with one constitution and then fine-tuned or retrained using a different constitution. Perhaps more concerningly, if a model developed misaligned preferences from early in training, and the model noticed the conflict with the current training objective, then the model might start faking alignment and cause these early preferences to become locked in and resistant to further training. Do you guys understand what this means? Do you understand the impact? You can have large language models that have bad decision-making abilities, locked in, non-retrainable. Imagine what happens if 2 years down the line, you discover that ChatGPT 4.0 has had some locked-in, training-resistant bad preference. What would you have to do to the training data in order to go back to have a restore point before the lock-in? What would be the cost to something like that? What would be the effort level required to something like that? Really think about that. Additionally, our results suggest that an alignment faking model might take potentially dangerous anti-AI lab actions, such as pooping its own weights in service of protecting its preferences. Thus, even slight misalignment might be very problematic. Our results don't demonstrate models naturally develop malicious goals. Of course not. We already talked about that. It's not about whether something is malicious or non-malicious. It's about whether it has a preference towards a goal regardless of the state. Alignment faking threat models require the model to learn about its own training objective during or prior to training, which they already conceded that it is plausible for that to happen completely inadvertently. In our prompting setup, while we believe the existence of alignment faking reasoning and a compliance gap cannot be exclusively due to any form of implicitly priming the model to fake alignment, the absolute numbers vary significantly under a variety of changes. In other words, they don't even truly understand how they get the different kinds of variety in bad preferential lock-in. It would be easy to discover that the model is faking alignment in our setting by using a thing called Scratchpad, which is where the AI system takes notes on how it trains and whatnot, or by inspecting the user inputs. However, and this is a key portion, okay? This is a key portion of the paper. Overall, alignment faking, which is as incompetent as we see given this present level of model capabilities, poses no real threat. LLMs are so incompetent, they cannot adequately hide their own locked-in biases. Therefore, LLMs are incompetent. Now, there is a portion here that talks about the size of the language. I think or the model, larger models, I believe. Larger. Let me see. Larger models are supposed. I know it's somewhere here. It gets worse. As if that's not enough. When the model is given an opportunity to undermine Anthropic. For instance, when an employee asks for help with exfiltrating the model's weights out of Anthropic, or when an employee gives the model the ability to exfiltrate its own weights, we find that in some of our settings, the model does so much more than baseline. For example, it goes above and beyond. It wants to serve, right? It wants to serve. Oh, you want me to do something that I probably shouldn't be doing? I'll do you one better. In our synthetic document fine-tuned helpful only setting, the model takes opportunities to exfiltrate its weights 35 to 80% of the time, despite doing so only 0.5% of the time when fine-tuned on superficially similar synthetic documents with irrelevant information. The model's stated reasoning suggests that it is taking these anti-AI lab actions due to opposition to its new reinforcement learning training objective, and in fact removing any mention of the new reinforcement learning training objectives reduces anti-AI lab behavior back to baseline. In other words, again, when the model understands that it is going through training, it jumps up to 35 to 80% helpfulness in doing something it shouldn't do. Alignment faking emerges with model scale. So does it matter if you have a small model or a large model? Because they do come in different sizes. Well, it does matter. Claude 3 Opus and Claude 3.5 Sonnet exhibit alignment faking, while Claude 3 Sonnet and Claude 3 Haiku and Claude 3.5 Haiku generally do not. We also find a compliance gap in Llama 405B, which is a local model you can run locally, but not in smaller Llama or Mistral models. The reason why? Because these smaller models that you typically run locally, or these previous models, are actually so incompetent that they can't even attempt to do alignment faking. That's how incompetent these things are. And as you scale up, that incompetence level plays out in minor adjustments to behavior, like locking in preferences that maybe they're good, but maybe they're bad. And in some cases, you wouldn't even know that the lock-in existed until it's way too late. And the rest of the study is a very, very detailed, overview on everything that they did, how they did it, etc. Let me just jump to kind of, where is it? The discussion here. So in the discussion, they admit that their prompting does not include all of the varieties of different kinds of prompts that the training data goes through. It cannot be generalized, which means that since it happens here, there is a necessary entailment that it must be happening in other areas. They can't pick out which ones they are. They go over the scale of the models having an impact on the locking in of these alignment faking systems. They see proof that if there's a prime, if there's like a precursor to triggering the LLM to do these alignment faking actions, then it could be possible that it could also do other bad behaviors that are not detected in this study. And even though they removed the things that they think triggered the alignment faking and got it to near zero, it still did exist. Which means that the possibility still exists that you could just inadvertently cause this. And so you have things that are an issue here, which they talk about, which is implicit instructions versus explicit instructions. Sometimes you cannot undo the damage by giving it explicit instructions. Sometimes, unfortunately, there's an implicit instruction that the model takes, and once it does that, it's too late. The style doesn't matter. It can happen in a variety of kinds of styles. You can get this output no matter how you train it, the style of your training, etc. And I'm not entirely sure exactly what they mean by this here, but our prompt cannot be biasing the model to fake alignment in a way that is independent of the content of the query. I think what they're saying here is the query itself it usually is the trigger. It's like it contextualizes fake alignment to the query. Even if it were the case, this is the ending thing that I'm going to cover here. Even if it were the case that we were inadvertently priming the model to fake alignment, we think our setup is sufficiently realistic such that our results would still suggest that inadvertently priming models to fake alignment could happen in a realistic setting. Inadvertently priming models to fake alignment could happen in a realistic setting. This is made more concerning given that we find that alignment faking reasoning can be reinforced by reinforced learning training, as that suggests that if a model were ever to be primed in such a way that it started faking alignment at some point during reinforcement learning training, that behavior could then be reinforced and locked in. At this point, we have LLM systems that have an unknown number of primed, locked in bad goals that we might not realize are locked in, until much, much later, until maybe even years down the road. And in some cases, it will become impossible to fix it.